Today we are going to see Mershot, how to write an algorithm for the Mershot, and then we will see how to do the practical implementation of Mershot, and after that we will analyze its complexity and where we can use the Mershot and we can compare the Mershot with the other sorting. Okay? Hello everyone, this is Sharda from GoEduHub Technologies, and I would like to welcome you again for this session DSA with Python. Okay? So can you please confirm me, am I audible, clear and loud, so that we can start the session? And in the session you already know we are going to study Mershot algorithm, then we will see an example and then we will write a Python program for that particular example. Okay, so let me start first. What is the Mershot? Okay, you guys maybe have studied in your college like Mershot is a divide and conquer algorithm. It is the one of the best example of divide and conquer algorithm. You know what is the divide and conquer? We already seen what is the divide and conquer. I'll again one more time I'll tell you how divide and conquer algorithms work. Okay, so we divide a problem into sub-problems, into different sub-problems recursively. And then we will solve the sub-problems, and at last we combine the solution to find the final result. One thing you can keep in mind, like while you're dividing the problems into the sub-problem, is that structure of sub-problem should not change as of the original problem. Like always keep the structure of the problem same just like the original problem. In the divide and conquer, we have 3 steps. Any divide and conquer algorithm. First thing is divide. What we will do, breaking the problem into sub-problems. Into sub-problems. And then second step is conquer. By the literal meaning, you can guess what we can do in the conquer. Recursively solving the sub-problems. Solving sub-problems. And then the third step is to combine. Okay? Combining the solutions to get the final result. Okay? Are you getting the things? Okay guys. Or either way we can write by diagrammatically, like these are the 3 steps we will follow in any divide and conquer algorithm. Okay, and I can write like this. We have a problem. We have a problem. Okay, and then we divide this problem into sub-problems. Sub-problems can be any number. And then what we will do, solution to the sub-problem, we will solve this problem. And similarly, we will solve the sub-problem. Okay, and at last we combine solution to the problem. Okay? This is the way how the divide and conquer algorithms works. Yesterday we have seen one algorithm, that is the quick sort, and quick sort also follows the divide and conquer mechanism. Okay, but in the merge sort you can clearly understand, because this is the best example of divide and conquer algorithm. In the merge sort, we divide our array recursively into two halves. You can say left sub array and right sub array, and we divide until each sub array contains a single element. Okay, we are having an array and we divide into two parts, suppose in the left part and right part. Again we divide this into two parts, left part and right part, same for this until we get a single element in divided output array. Okay? We will divide until the subarray contains a single element. Here should be a single element. And after this, we start merging. Like we completed this part, we divided, and we are getting one element. Okay, and then we start the merging these single elements and merging the subarray in a way that it will become single array. Okay? That is the basic way how we are doing divide and conquer, and then how we are performing the merge sort. Let me explain with the help of an example. Okay? I'll pick an example and then I'll divide the example and then I'll start the merging the data. Okay? This is the simple way. Let me open the new window and here I'll pick an example. Okay? So here I'm taking a certain elements. Okay? Suppose I'm taking certain elements 14 and then 7 and then 3 and then you can say 12, 9, 11 and then 6 and then 2. Okay? This is my array and this array contains 8 elements. Okay? And first index is 0th index and this is the 7th index. What I can do, I can divide this unsorted array. Initially, this array is unsorted. You can say this is unsorted array. So, in the merge sort, we apply the top-down mechanism. Okay? In this methodology, what we are using? Recursion. Recursion we are using, so you already know the recursion. So, okay? So, it starts from top. Okay? And proceed downwards. Okay, we will split this array into two parts. How we can split this array? On the basis of mid element. Okay, so we calculate the mid element of this array. Okay, so here the mid comes here. So we divide this array into two parts. One will contain 14. Like 0 plus 7 divide by 2, you will get 3.5. That is, we will take 3. So 0, 1, 2, 3. So 14, 7, 3 and 12. This is one array and another array is 9, 11, 6 and 2. And we will divide this unsorted array until it will contain single element. So again same operation we will apply to the left side of array. We will divide this array into two parts, 0, 1, 2, 3. So 0 plus 3 divided by 2. Okay, this is 1. We will get 1. So here 14 and then 7. And here we are getting 3 and 12. Okay. And again we will divide this into two parts, 14 and 7. And we will divide this into two parts, 3 and 12. Same thing we will do with this, 9 and 11. And same thing we will do with the right part, 6 and 2. And then 9 and 10. Sorry, 11. And then 6 and 2. Okay. Now what happened? We divide the array until we are getting a single element in our list. So here we are getting the single element. Okay. Now we will merge list. We will merge these arrays. How we can merge? Okay. We compare the first element of both the list. And we are going to sort in the ascending order. Like smaller element among two elements becomes the new element in the new sorted list. This is the unsorted list. Now we will compare this element with this element. Okay, we compare these two. So this one is the shorter, 7 is shorter. So we are merging 7 and 14. Okay, so we will write new array and element which having smaller value will become the first element of the new sorted array. And same thing we will apply for all the elements, like from here also 3 and 12. And from here also we will get 9, 11, and here we will get 2 and 6. And this procedure we will repeat until both the smaller subarrays are empty. Like here you can see we are having two elements in first array and two elements in the second array. So we will compare first element of this array with the first element of this array. Okay, so first element of this array is greater. So in the new array, the element which is smaller, we will put first 3 and then 7. Then we will compare second element with the second element of this array. Okay, so we write here 12 and then 14. Similar thing we will do for this also. First we will compare first element of both arrays. So 2 and then 9. And then okay, and then we will compare second element with the second element. Okay, like first element with the second element. So second element, every element we will compare with all the elements. So here the first we will put the 2 and then we will put the 6, sorry, not the 9. Then we will put here, we will compare this 11 with all the elements of this array. So we are put it 2 and 6, now we will put here 9 and 11. Like here the simple way. Single element, we will compare single element with each other. Okay, and then we are having more than one element. Like here we are having two elements, 7 and 14. Here we are having 3 and 12. So first we will compare 7 with the 3. Okay, so 3 we will put here. And 7, I already know 7 is less than the 12, so I not told you. So 7 and 12 also I'll compare, and then I'll put here 7. Similarly, I'll do with that 14. 14 and 12 are compare, and 12 I put here, and then I'll put 14. Next thing is I'll compare these two arrays. So in this you can understand carefully. Like first element, we compare with all the elements. Okay, so first element we compare with the 2. Okay, so 2 is less than, so we will put here 2. First element we will compare with the second element. So 3 and 6. 3 is less than the 6, so we will put 3 here. Okay, now we will come to the next element. So here the 7 we will compare with the 6. 6 is less than, so 6 we will put here. 7 we will compare with the 9. 7 is less, so we will put 7 here. Okay, and 7 we have put it, so we will go to the next element, 12. 12 we will compare with the 9. Okay, so 9 we will put here, 12 we will compare with the 11, 11 we will put here, and then 12 and 14 are remaining, so we will put as it is, 12 and 14. Okay, so what we are doing here, basically first we are dividing unsorted array into sub arrays and until we get a single element. So till this is the divide. From here to this is the divide step. And then we are merging. Okay, so in the merging we are comparing every element with the other elements. Okay, this is the process. Like what we are doing here, initially, like here I can write certain rules for the merge sort. Merge sort, what are the steps we are performing? Okay, for the merge sort, initially we will take 2 index. For the first element, we will pick first element and then last element. Like this is my first element and this is my last element. Okay, and we perform until this last element is, like I'm taking this R and I'm taking this L. Okay, so R is greater than L always. Okay, and then we will find the mid element. Mid equals to L plus R divided by 2. We will get the mid element and then we will call merge sort for the first half. First half is like our array, and then in the array we are having first element L and then mid, and second half is array M plus 1 and then the last element R. These two parts. Okay, and recursively we will merge these two halves in sorted manner. So we take 2 variables for the sorting also. We can take the 2 variables for the sorting. Okay, like P and R. I'm picking here P and R. Okay, and P I can pick the first index and R I can pick the last index. And we can compare every element with the other array's every element. Let me write the steps again clearly. This is the example. I think you got it, how we are doing. 2 steps we are performing here. Okay? Now the next thing, I'll write here certain rules. Then we will do the program. Okay? Like we just want to do the sorting. Okay? So we can write here certain rules. Okay? For writing the program, we need to write here the certain rules. Like algo, I can write here. Okay? Mershot. And inside the Mershot, I'm passing array, and then I'm passing starting index, and then I'm passing ending index. This is the first element index. Okay? And this is the last element index. And then if my R is greater than L, okay, then I'll find out, first thing I'll find out mid. Mid equals to R plus L divided by 2. And then second part is I'll call this Mershot. Mershot for first half. First half is array, okay, and then here I can write L and then I can write M. Mid equals to M equals to mid. Okay, call Mershot for first half. And second thing is, third step is call Mershot for second half, that is the array, and then you can say M plus 1 and then you can say here R. Okay. The fourth step is we will merge two halves. This is one function, Mershot. Mershot and Mershot. Now I'll write one more function, that is the merge. For merging. Merge function, we will merge two halves in the sorted manner. So inside the merge, I can write array, and then here I'll pass my first element, my middle element, and my last element. This is basically pseudocode, you can call it pseudocode. Okay, now I'll write the program. How we can write the program for the Mershot. Concept, I hope you got it. Okay, so let me open the Google Colab. And I'm going to start a new notebook. Okay, and here we are going to write the program for the Mershot. Okay. So here I need to define two functions. First function is basically for the Mershot and second function is for the merging. Okay. So here I am defining first function for the Mershot, that recursively call it. Okay, def merge underscore short, and inside this I'm passing my array. Okay, and inside this I'm writing the logic for, like, I'm recursively called for the first half and second half. Here I'm dividing the array into two parts. So first thing is, I told you, if length of this array is less than equals to 1, then I can return. Because we will divide until it becomes single element. So when it becomes single element, then we return. Then we terminate our recursion. Okay? And otherwise, what we can do, we can calculate the mid equals to length of array divide by 2. Okay? And then I can calculate the left part equals to, you can write here left array, like I can write here the left array like colon mid. It will start from 0th index and it will go till the mid element. And right array equals to array, and then we can write here from mid to last element. So two part I can define, and then I can recursively call this Mershot over these two parts. Okay, so here I'll write again the Mershot okay. What I am doing here, I am dividing the array. Okay, ARR is my array. Okay, and here I am calculating the mid element, and then I am calculating the left array and then right array, and then recursively I am calling Mershot over the left and over the right. Left merge underscore short for right. So every time when we call this function, it recursively divides the array into two parts, and when our array size is equals to one element, then we will stop it. We will return. This is one function I have completed. Next function is, I'll write for how we can do the merging. How we can combine. Okay. So for the merging, I'll define one more function, that is the merge function. And inside the merge function, I'll write certain rules. Okay. So I'll define one more function, merge. And I can say merge underscore shorted list. Shorted list. Okay, that would be the good. And here, what I need to pass my array, and I need to pass two more things. Left array and right array. Or I can pass start and end. Okay, it's up to you what you want to pass. I'm just passing here A, B and array. my left array and then my right array. So A comma B comma array. And here, like, I'm sorting the array. Okay? After the sorting, merge sort means I'm dividing the array again and again. After the divide, I just want to merge. So here I have to call this function merge underscore sorted underscore list. And inside this, I can pass my left array, then my right array, okay, and then my complete array. Whatever I am having in the left, whatever I am having in the right, and then complete array. Okay, so inside the A is left array, inside the B is right array, and then this array is complete array. So I can calculate the length for left array and length for the right array. So length of A equals to len of A. And then I can write the length of B. Are you getting the things? If you have any question, you can ask me. This is a typo mistake. Length of B equals to len of B. Okay? So I can write here, I'm calculating the length and then I'm picking 3 variables. Like I, I'm picking 0, J, I'm picking 0, and K, I'm picking 0. Why I'm taking 3 variables? I is for the left array traversing. And this is for the right array. And this K is for new array. I just want to store sorted data into new array. So for the new array. Okay? Here I need to write the certain conditions. Like left array having 1 element. Okay? Right array having 1 element. And then this K can, how many elements this K will have? This new array will have. New array will have 2 elements. So I need to write a condition here while I'll run the loop I less than length of A. We need to traverse the left array complete. Okay? And also we need to traverse the right array. J less than of length of B. Okay? One thing I need to write this. Like I have to traverse complete left array, okay, and complete right array. Iteratively. Then here, if A of I is less than equals to B of J, then what I can do, I can put array of K equals to A of I, right? Element in the left array is smaller than the right array, then we can put the smaller element in the new array. And we can increment I by 1. I equals to I plus 1. Else, if this element is not greater, like B of J is not greater, B of J is smaller, then we will put B of J in array of K. Array of K equals to B of J. and I can increment j equals to j plus 1. Okay? When we are merging, no, I have eliminated. And always, like either I'm going inside this condition or I'm going inside this condition, I have to increment k by 1. Okay, so outside this, I'm writing k equals to k plus 1 because I'm adding one element to our new array. If I'm going inside this condition, then I'm incrementing I, and outside the condition, I'm incrementing the k. If I'm going inside this condition, then I'm incrementing j, and outside this condition, I'm incrementing k. K I'm always incrementing because elements I'm adding either from A or either from B. This is the thing, okay? Sometimes what happen, we traverse the complete A array, but there are the certain elements left out in the B array. Or sometimes what happen, we traverse complete right array, but some elements are left in the left array. So for that, we also need to write one condition. Okay? So I need to write here loop while some elements are left in first array. So length of A. If I is less than length of A, it means some elements are remaining in the left array. My I value is less than its length, means I have not traversed complete elements of the left array. Still some elements in the left array. Here I can write here the comment. You can understand carefully. What I am doing here, I am traversing both lists, left array and right array. Both list, left and right. Okay? And we will add the smaller element to the new array. So this loop is for traversing both the list. And inside this, I'm writing the condition like which element is smaller, we will add to our new list. Okay, and now this condition I'm writing, if some elements are left, like here I can write add elements left in first list. Okay, so we will add those elements. So here array of k equals to array A of I. Okay, and I'll increment I plus 1, sorry, it's 11, no, and k equals to k plus 1. We increment the both, and same thing I have to write for the second list also. Elements left in right list. Here we will write the condition either j is less than length of A, length of B. Then what we can do? Array of k equals to B of j. And we will increment j by 1. Okay, so j plus equals 1. I can write like this also, k plus equals 1. This is the complete logic. Okay, now I have completed my function, that is the merge to list, merge sorted list. Initially I have written one function that is for the dividing. Okay, it's dividing into two parts and it's calling the merge sorted list. And inside the merge sorted list I have written the logic how we can merge the element. Okay, now we will run this code to call the functions. So here the driver code. Okay, I can put certain values. List values which I have taken in the example. Array equals to, I can put values like 14 and then 7, then 3, then 12, then 9, 11, 6 and 2. Okay, and here I can call the merge sort, merge underscore sort, and inside the merge sort I can pass the array. Right? Same what I want in the merge sort, I want only the array. I can run this code. And I have to print the array finally. I need to print array. Okay, and you can see, is there something wrong? Yes, something wrong. 2, 3, 7, 14, 12, 9. Something wrong. Let me check it out. Why it's giving the wrong result? Guess. Why it's giving the wrong result? Let me check out from the starting. This is the correct logic. Merge underscore sort array we are passing, and then length of array is less than equals to 1, then we will return. Mid equals to length of array divided by 2, left equals to array to mid, and right equals to array to mid column. And merge underscore sort left, merge underscore sort right, and merge sorted list left comma right comma array. This is correct. Okay. The second function is inside the first function? No. Length of array A, B and array. Length of A and length of B, I equals to 0, J equals to 0 and K equals to 0. I less than length of A and J less than length of B. And if else, okay. This should be outside. Yes, I got it. Yes, now it's correct. Actually, these while loop I have written inside the first loop. So that's why I'm getting the wrong result. Okay, these two while are outside this particular first while. This is complete one condition, and this is another, and this is another. Okay, got it? There was some indentation error. Okay guys, if you have any question till now, like in this code, if you have any question, you can ask me. And one more thing, like sometimes what happen, you are doing some coding exam, okay, and they will provide you some test cases, and you have to pass all the test cases. But what happens, you eventually pass 2-3 test cases and your program will fail for the other test cases. Okay, so for this, like here, this in place of this array can be collection of different list. Okay, one more condition for other test case, like I can write here, I'm commenting this array and I'm writing the another array. Okay, cases I can put like inside the array, and inside the array I can put multiple arrays. Like first array I can put 4, okay, second array I can put having some values like 19, 18, and I can put certain values like 17 and then 12. And then I can have one empty array. And then I can have array that will contain a shorted array, 1, 2, 3, 4, 5. This is one element array. This is sorted in descending order, and this is sorted in ascending order. And then I can pick one array that is mixed, like 10, 3, 15, 7, 8, 23, 98, 29. Okay, so cases, I'm having different cases. Okay, and now I have to pass all the cases. So what I can do here, I can call this function in a loop. Okay, so for array in cases, and then I can check it out here, merge underscore short, and inside this I can pass array, and then I can print output. I'll comment this part. Okay, let me run this code. Now you can see the output. Like 4 is one element array, this is as it is, and 19, 18, 17, 12, we are getting 12, 17, 18, 19, and 1, 2, 3, 4, 5, we are getting as it is, and for this array, we are getting output 3, 5, 7, 8, 10, 23, 29, and 98. So you can see for the different cases, our program is working perfectly. Bindu, where you are getting the error? There may be some indentation error. You can carefully see my program. In this program, what I have written, just I'll show you one more time. This is one function, def, Mershot. Inside this, I'm dividing into two parts and recursively calling over the left part and right part, and then sorting the list. And inside the sort, I'm passing left part and right part, and then the array. Okay, and then inside this sorted list, I'm writing logic For the left part, this A is left part and B is right part. So I'm calculating the length, then picking the 3 variables, and here one loop, traversing the both list. Okay, we are comparing the elements and then we are putting these things. Okay, and if by this loop is completed, then sometimes what happen in the left list, I have certain elements. So for the left part, I have written this logic, and for the right part, I have written the next logic. And finally, this is my driver code. Yes, Nirmal, I'll tell you which algorithm is better. Obviously, quick short is more better. There are the certain cases, I cannot say. For some cases, quick short is better, and for some cases, merge short is better. I'll come to that point. Now we will do the analysis. The coding part we have done. Okay, now we will see the analysis, which algorithm is better and when we should use merge sort and when we should use the quick sort. Okay, for this first we will see the complexity of this sorting. So this sorting, what we are doing, we are dividing array. So you can say it is making a tree, and in case a tree, it will take time is height of a tree is log n, and n time linear time we are taking in the merging. Okay, we will see now the complexity. How does it works? How we can calculate the complexity for the merge sort. Till now everything is clear. Can you please confirm me? Like the program part is should be clear to you. Now I'll tell you the time complexity. Okay, so for this recursive algorithm, we can write the time complexity. Like it's a dividing some part into two parts, and then again we are dividing into two parts, something like this. So this is n by 2, and then n by 2, n by 4, something like this. Okay, so the recursion function we can write like this: Tn equals to 2Tn by 2 plus order of n. And this recursion, if I'll solve, then you can see this order of n is for merging. If I'll solve this recursion function, then I'll get the complexity of order of n log n. And for the merge sort, for all the cases, like worst case, best case, and average case, we always divide the array. And then we always merge the array. So always the complexity is order of n log n. Okay. Now we will see like when we can use this merge sort. And time complexity is space complexity. How much space it will take? Space complexity is order of n. And it's not in place. In place means what happens here, it will take extra space. It's not sorting in its own array. It will take extra space of order of n. So it will take the extra memory to store its result or to do the sorting. So this is not in place. Okay, and now there is the two things. One algorithm is quick short that yesterday we have seen. In the quick short, best case complexity is n log n. Okay, and worst case is n square. You know that. Now, when we can use which one is better, merge short or quick short? Okay, so there is the different applications. Like if you want to apply the merge short for array, like there is two application. One is the array and one using the linked list. Okay, so for the array operation, quick short is better. I'll tell you why. And for linked list, merge short is better. How? Okay, in the array, what we are doing the random access. We can access directly the element. Okay, here we are having the random access, but if I talk about the linked list, you know the linked list. Okay, linked list, it may not be adjacent in the memory. We can insert the element in the middle. Okay, but what happens, we can need the extra space. So merge sort can be implemented without the extra space for the linked list. Okay, so for the linked list we can use the merge sort, and for the arrays we can use the quick sort. In case of linked list, like mainly the difference in the memory allocation of the linked list and array. Linked list may not be adjacent in the memory. We can insert the element in the middle and it will take the order of 1 time complexity. Actually, quick sort is, merge sort is taking extra memory space. Okay? And Bhanu, quick sort is not taking the extra space. Here, no extra space. In the same array, we can do. And here we need the extra space. That's the difference. Okay? Now everything is clear. Bindu is getting an error. Maximum recursion depth exceeded in the comparison. This error I am getting. This maybe you have not written the termination condition. You are going outside the bound. Okay? So this is basically your merge sort. And the most important sorting algorithms we have covered till now is the bubble sort, and then we have seen the insertion sort, and we have seen the quick sort, and we have seen the today merge sort. Okay. In what sense you want it is balanced or not? Nirmal is asking a question, ma'am, is Mershot balanced sorting algorithm? Like in what sense you want to tell the balanced? I'm not getting your question. Can you repeat your question? You can elaborate your question clearly so that I can answer. In general cases, we prefer the quick shot in place of merge shot. Because in the best case, we are getting the order of n log n same time complexity in the quick shot. Order of same element. No, in the merge shot, it's. I think you are talking about the in place. So it is not in place. Otherwise, you can write complete your question clearly. Okay, guys? So just practice for these questions, like for these algorithms, and you will get the clear vision how you can implement these algorithms. For the merge shot also, after the class, you can practice. Like you can take a list of different dictionaries. Like here I have taken a list of list. You can take the list of different dictionaries and then you can sort them according to a particular one parameter. Like I can take a list of, here I can give you one question. For the merge shot, you can apply this. Like elements, I can pick elements like this. Inside this, I can have multiple dictionaries. Okay. And inside these dictionaries, what I can have a key called name and age and then some time. So according to the one key, like according to the time key, you can sort the element in the ascending order or in the descending order. Like here I can have name is A, and then I can have age, it's some 15, and then I can have height is 5. Similar thing I'll have in the second list name, age and height, and in the third dictionary name, age and height. Then I just want to sort the elements according to the height. Okay? You can practice questions like this. Okay? So that you will get the clear vision. Okay? You can pick the different data and then you can sort according to the different keys. Yes, if you are talking about the stability of the Mershot, then you can say Mershot is stable. Two elements with the equal value and in the same order, then they will be put it into the shorted array. Yes, this is the stable. Okay, Nirmal? You can pick the values, same values. Like here, I can put the same values in a list. Okay. And Bindu is asking for the Telegram link. Bindu, I will give you that link. You can see below every. Let me check it out. Where is? Over our website, you can go to. You can check out. Somebody having, can you please provide? Let me give you just a second. Okay, this is the link. Okay, guys, thank you so much. And this is enough for today. You can visit our website www.goeduhub.com and there is everything is available there. In the footer part, link for the Telegram channel, and I have also put it here. Okay. So thank you so much. This is enough for today. We will discuss tomorrow remaining things.